function of x, and same thing here, u and u, and u and u. Okay. No, you.
Hey, you.
So basically, you're going to use this new substitution right here, this beta substitution, when one of these guys are in your integral, okay? If you see those in your integral, then this is a process that you could use, an integration technique. Right? Right.
Oh my gosh.
Now, this one I hope you all can tell me the answer in less than 5 seconds. Does arc sign have 1 over a?
No, it doesn't. That's arc sign.
All right. So that one, you could just do the arc sign rule. I'm going to show you a different way of doing this. I would not choose this way if I saw that, but so you can see you get the same answer. Okay? In this option, we would definitely want to use arc sign. In other ways, other problems I give you, you don't have an easy option. Okay? Would you ever think arc sign is the easy way? All right. So the different approach, and I'm going to take you through the steps. The first step we're going to do is identify the substitution. So make your u equal a trig beta substitution. Okay? So in this case, when I see 9 minus x, right, I see an a minus a u, I should think
You.
okay, hold on. Let's go back to these really quick. Okay. When I see an a squared minus a u squared, I should be thinking sine. When I see an a squared plus a u squared plus, I should be thinking tan. When I see a u squared minus the a squared, I should have been thinking c. And that's kind of prior knowledge, right? Okay. So when I see this guy, my a squared minus my u squared, I'm going to think my substitution here is going to be the sine. So what's my u? Okay, so my u is the x. My a is 3, and the trig thing I want to use is sine. So that's the substitution I want to make. And go ahead and get your dx. Knock that out with why you have that already. Okay? So that's the substitution we're going to be making. Okay, step 2. Solve for your sine theta, or in general, hold on, let's just say, solve for our trig theta and make a right triangle. So that's our kind of in general. So let's look at it here. So basically I know that sine theta equals x over 3. So I'm going to make my right triangle with that. Sine is x over 3. And fill in your other side. Okay. What did you get for this side? Radical 9 minus x squared. Right here, we're going to pause. Okay? Pause for a second. You're going to do a little self-check. Did this radical match happy to move on. If it didn't match, you're not on the right track. Back up and redo some things, okay? But that's a little pausing statement. Okay. What was that? Step 3. Find your radical over the number equals your trig theta from the triangle. Okay, so what does that mean? Okay, so you have to figure out what's that going to be, basically. So in this case, my radical part is radical 9 minus x squared. My number part is 3. And what relationship is adjacent over hypotenuse in this case? Okay, so that's going to equal cosine theta. Okay? Doing okay so far? Okay. Step 4. Sum in thetas. So no x's left. I gotta see our original problem. Okay, so our original problem was radical d, radical dx over radical, integral dx over radical 9 minus x squared. So, dx, looking back at what we have, do we have dx equals something with all thetas? We did. That was 3 cosine theta d theta. What about this guy? Do I have anywhere what that would equal? Yeah, that's what we used here. So that will equal 3 cosine theta. So that's actually going to equal 1 d theta. And the antiderivative of 1 is not x because we are in theta. So this would be theta plus c. Okay. You are not done.
I don't know. Let's just hit extend page on our papers.
Yeah.
Now we're going to go and unsub the thetas from the x's.
Oh my goodness.
I don't agree with that.
So in this case, I need to know what theta equals because I had theta plus c. So I know that x equals sine theta. No, or was it at 3? 3 sine theta? Okay. So theta is going to equal arc sine of x over 3. So theta plus c will be arc sine of x over 3 plus c. And is that what we knew it should be?
Actually, yeah.
Yes.
That was.
Okay.
For this problem,
So for this problem, I would not have chosen this method. I would have chosen the arc sine rule. Okay.
Wait, can you scroll back down?
But you don't always get the easy way out. Okay? Okay.
Each step makes me
Go back to the 90s.
no laugh.
So let's look at this one. Okay, let's look at
Pretty sure that's secret.
Is it arcsecant?
Looks like it. It's kind of similar.
I know it is.
Similar, but this is an x squared minus a 2 squared. So those guys have to
No.
be the same. That's an x.
Oh no.
Squared.
Alright. It was fun while that.
It's an arcsecant. No.
Can't be.
Okay.
So you use the long method?
So can you do a U sub?
I mean, probably not.
No.
This problem's a lost cause.
All right.
Just use it as well.
But I do see a radical going on with a u squared minus an a squared. So I should think this new method. All right. So u in this case is x equals a 2, and when I see u squared minus a squared, I should think which one? Secant. Beta. Go ahead and knock out your dx. You're going to need it.
Wait, hold on. Just a second. Why? Okay, got it. Okay, where's the 2 from?
Or
The A. Got it.
2 squared.
Yes, thank you.
Okay. Well, now I'm going to make my triangle. So secant is x over 2, so cosine would be 2 over x. Is that all right?
Yeah.
Is that okay? Yes or no?
Yes.
Okay.
Yes.
Where is that?
I'm gonna have a whole other.
So I know that x over 2 is secant, so cosine is 2 over x. Fill in your remaining side. 3 0. And pause. Does that radical match the radical of the problem? C. Nathan, you alright? Okay. Josephine, does that radical match the radical of the problem? Yes. So can I keep going?
Yes.
What's my next step?
The radical is
Okay. So what's the radical over a number? In this case, the radical over this number equals what relationship? 10. Right? Opposite over adjacent.
Oh.
Oh.
Tangent.
Now go fill it all in. You got all the information you need to go fill it in.
Okay. Now, wait, didn't help. I don't want to.
Yeah.
What? Huh?
Okay.
Oh.
Oh, that makes sense.
That's from my dx. That is from this x squared.
Yeah, I can't.
And that is from the radical.
Okay.
Wait, that equals, wait, hold on.
Right there.
Wait, where's the bottom coming from?
Yeah.
Read that. Where's the bottom coming from?
Okay. So that is from my dx.
Yeah.
This is from my x squared.
X squared equals.
And this is from that substitution.
Alright. I'm starting to get it. Oh, yeah, okay.
Okay, reduce and integrate.
Reduce.
Okay.
We can close.
You cannot get to that. Ask me for help.
I need help. Oh.
Two on top and two on bottom.
No, there's a two there. What?
Wait, I got that.
Wait.
I got that.
Will help.
Okay. Alright. So you pretty much you can take that and
Yeah. What if I
so
just
you
go?
do see that actually
But I have two here. I'm choosing a two hit that.
you want to
Oh, duh.
that's
Ah,
okay.
yes.
Oh, yeah.
Oh.
So then it becomes
Why do you do it? That's my road.
Oh, wait, no, we're not using it.
It'd be easier to take out this. You touch it?
Get that part?
No.
Get an extra slice of bread.
All right.
Just 1/4 time.
Did everybody get to 1/4 cosine d theta integration?
Yes.
Wait, no, hold on.
Raise your hand if it's not. All right. So now take your antiderivative.
Hold on, let's do this.
Yeah.
wasn't that bad.
Wait.
Okay.
It's always impossible.
Are you done?
No.
No.
Oh.
You started in x's. You have to end in. Oh. Okay. Sine theta. What? How do I know what sine theta is?
That one right there.
I don't have any
You got a
sine.
triangle.
Oh, I heard
You
it.
have a triangle.
We have a triangle.
We got this thing.
Okay.
We do have.
Use the right triangle. What is sine theta going to be equivalent to?
Radical x squared minus 1.
Radical x squared minus 4 over x. 8. Oh.
Now we're done.
Now you are done.
That is the
So,
ugly answer I've ever seen.
That was a journey.
That's not.
And it's pretty-
Liar. So there's been like 3 problems on top.
Oh, no. All right.
So I think we can't move on.
Oh, God. That is bad.
Yeah, that's not. Refer to triangle. Would you suggest changing it out or should we do back?
I'm gonna change them. You're gonna have to do it eventually. Get it done.
All right. Start it. Oh, hey. Pause. Pause. Okay. Can I hear you, Seth? The powers are different by 1.
No, no. The radical.
Probably not. No, so that's x to the negative.
That's a radical
Okay.
top.
So if I did a use sub here, because I think a lot of you would think, hey,
That's what I go.
oh, hey, I actually 1 over x dx, right? Is that anywhere close to that? No. So u sets will not work here. What's gonna work here? Substitution. Yeah, trig substitution.
No.
Okay. Okay. Get it set up for me. Do what you can, and then we'll kind of regroup. We'll talk about the balance here in a little bit. Do what you can first. We will.
Okay.
Will, talk about the balance.
Talk about this.
U squared minus a squared v2.
Oh my God, this is ridiculous. Okay, so what's the first step? Hydrogen to get a trig substitute.
So that's my first. I kind of like find my u and my a. Is that okay? So now
I can't read that.
go ahead and knock what out. Go ahead and get rid of, like, I know I'm gonna need this, so can I go ahead and just get that out of the way? That makes sense. Go ahead and just knock out your dx. So what's that?
Oh, wait, x over revenue.
And then what's the derivative? Don't forget to write it. Now we're going to take this and make our right triangle. So x over 5 is 3 over 6. Is that okay? So I'm going to go ahead and flip flop this. It's easier for me to see. And I'm going to say what cosine would be.
Well, I'm not there yet.
Okay. Now when I make my triangle, pause. You forgot the pause. Cosine over what?
Swerve, you didn't pause.
Is it too late to do that?
Pretty.
Alright. So now from the triangle, I'm going to find my radical over my number. So my radical over my number. And what relationship? Opposite over
Wait, what's the number?
Okay, now here, I have all the information I need to sub into my okay, sub into our
Don't stop.
Yes, it is. Opposite over adjacent. How do you integrate it?
Opposite of
How? What?
Okay, Tyler.
No.
I used that. Why not over?
Yeah, look.
Really what if we get the wrong answer?
Okay, I hope that you are all to this place.
Okay, hold on.
Let's talk. Ask me a question if you're not, one at a time. Josephine. Okay, so that was with this guy right here. And I used from the, remember we have to do the radical over the number? So I used this information, solve for that radical. And now I can substitute that in. So the information I pulled, I find what the radical is equal to, and sub that in for the radical.
Oh, okay.
Okay? Okay. What is different? Let me have your focus now. What is different in this one? Okay, we can do that. But what did I leave off? Okay, the bounds. But yeah, we'll go back to that. I need to know what are my new bounds.
Oh.
When I make a substitution, I also have to change my bounds, right? Yes. Okay, so my new bounds, let's see, I started with 2, and I started with radical 3. And I need to find what those new ones are going to be in terms of, what here? Theta, okay? So I know that x equals, okay, x equals radical 3 secant theta. So I'm going to plug in what my x would be. So 2 equals radical 3 secant theta. So 2 over radical 3 equals secant theta. So radical 3 over 2 equals cosine theta, which tells me theta would be pi over 6. So where I had my 2, that was at the top, I'm going to put pi over 6. So now let's do our radical 3. Where does that happen? 0. So this spot I get to put a 0. Now, Katie Ellison, this becomes a 7.3 problem. 1 minus secant squared. Secant squared minus 1. Sorry. squared minus 1.
Wait, can't you pull the graph?
Yeah, you can.
Almost did it again. Secant squared would be tan theta minus beta, not x, we're in terms of beta, evaluated from 0 to pi over 6. Work on that, and you should get,
No, don't spoil it.
okay?
Nailed it. Minus pi and 3 over 6.
Alright, 1 minus radical 3 pi over 6. That is that problem. Don't put your notes away yet. Okay. So I have a lot of problems. We're not going to do all of those with time constraints right now. I might go back to those for some review problems, but I do want to point out number 2 and number 5, some different things that can happen. So we're going to first look at number 2. When I look here, remember, I like to do the setup so I can see what it's going to be. This would be radical 7. This would be radical 3x. It is a squared minus u squared, so I should think sine. So if I was to do a substitution, then I would make what? Is this x now? Okay. It is now radical 3x. Don't always think it's just x. It's your u.
Okay.
Okay? So I just wanted to kind of make a note of that, guy. Okay? And then I think you guys will be fine. The other one I want to look at is this. You can write it down, or you can just follow along with me, okay? Because it's not until the end of this that I really want to show you the new thing. So let's just talk. In this case, this would be 4 squared minus x squared. So this you would think sine u equals a sine theta. Go ahead and get your dx. Make our right triangle. But anytime you're like, I have a question, pause me. So sine is x over 4. Fill in the remaining side. Pause. Is that the one that we had?
Yeah.
Okay. Pull out from here the radical over the number. What relationship is that? Cosine. And now we're going to sub in. Okay. So we had the integral of this guy, so it would be 4 cosine theta times my dx which was 4 cosine theta d theta. So that's 16 cosine squared theta d theta. And this turns again into a 7.3 problem. We're okay with that. This is the same as 1
Minus.
plus cosinus plus. Okay.
Oh, power
Cosine
reduced.
2 theta over 2 d theta. So this is the integral of, what is that, 8 plus 8 cosine 2 theta, or I could have just had an 8 out in front. Okay, so this is going to be 8 theta plus 8 sine 2 theta over 2 plus c. Sure. All right. Before, if I had sine theta, where would I look for that? Okay, in the triangle. But this isn't sine theta. This is sine 2 theta. We can't find that. So, what do we use? Okay. You know what sine 2 theta of u is equal to. So sine 2 theta is equal to 2 sine theta cosine theta. So use that substitute. Now use the right triangle and continue. Okay, so if you've got that double angle, guys, if you've got that double angle, it's the appropriate identity. Okay? Okay, so those are the other 2 things I really wanted to show. I would, if it was me, go and do one homework problem to get it in my brain before I leave the class right now. And then any other questions you have after that. Huh? I said, did everybody pick it out, Tyler?
Well,
And I had
I didn't
Tyler.
know some kind of dummy.
Tyler.
Oh, man.
Yeah.
You better do that.
Here, Tyler. My special one.
No, I got these. I just think you said it before.
Oh my gosh.
See, that's why I was confused.
History tells explain like the Civil War. Hey, see, Civil. I'm gonna finish all the homework 7 and 8 this week.
What?